Okay, I just wanted to look at the second problem from the three that I gave you to review that I think is very important for your test regarding related rates. And so this was a problem that read, a rock thrown into a still pond causes a circular ripple. And if the radius of the ripple is increasing by 2 feet per second, how fast is the area changing when the radius is 10 feet? So just as a reminder, you can find this problem in the course document slides section of your course compass, and it is in chapter 4 and in section 4.6. So the slides are there and this problem is written for you. But in essence, what it's telling you is that you have a circular ripple. So I've drawn a picture of a circle with a radius, and they want me to find, so I have to find dA dt at the instant that the radius is equal to 10 feet. So that's my unknown. And let me see if I can't write that a little bit better so you can read it. That's at the instant that r is equal to 10 feet. And that's what's unknown, so question mark there. And I know that dr dt is equal to 2 feet per second. So at every one of your related rate problems, I'm going to be looking for some things in particular. I'm going to be looking for your diagram. I'm going to be looking that you know what is the entity you have to find, the rate that you have to find, and that you can identify all the given information. So the next thing that you'll need to have in each of these problems, you need to have an equation that relates to variables. So we have an area of a circle and the radius. So we know the area is equal to pi r squared. So now we have an equation that relates to variables. The next thing we're supposed to do is get an equation that relates to rates. So I'm going to write the equation relating to variables one more time. Now I'm ready to differentiate both sides. I have to remember again that both a and r are functions of t, so they're dependent variables. Every time I differentiate one of those, I have to put their prime with it. So on the left, the derivative of a is 1 time dA dt, or just dA dt. And on the right, remembering that r is a function of t and that pi is a constant, so I get 2 pi r dr dt. So this relates the rates. Okay, so I've already solved for the unknown rate. This problem was rather straightforward in that regard. dA dt is what I'm looking for, and so I can plug in on the right hand side. Make sure I put in my units. So this is equal to 2 pi, r was 10 feet, and dr dt was 2 feet per second. If I look at my units, I think I'm going to get what I want because I have feet times feet, which is feet squared per second. So that is a rate change of area. Area is square units, and then a rate of change has to be divided by some unit of time. So then dA dt must be equal to 2 times 10 times 2. So that looks like 40 pi feet square per second. And now I have the rate at which the area is changing with the change in the radius.